Good morning, everyone. Today, my group and I will be presenting about IoT in healthcare in Malaysia. And to start off, I'll be passing it to Jasham to start.
Thank you, Shivan. So I will present the introduction of IoT in healthcare. What is IoT? Understanding the Internet of Things, a global network of physical items embedded with sensor and software, enables seamless data gathering and sharing across digital platforms, break down traditional barriers, unlocking new insights and possibilities. IoT in healthcare. The role of IoT in healthcare provide real-time data streams for healthcare professionals, facilitates personalized therapies and optimized workflows, allows remote monitoring of patient well-being. Remote patient monitoring. Benefits of remote patient monitoring, continuous monitoring of vital signs and medication adherence, enhance patient convenience and comfort, enables proactive management of chronic illness and early intervention, enhance collaboration and data exchange, fostering collaboration through IoT, bridge communication gaps between clinical decision tools and electronic health records, provide comprehensive insights for better informed decisions, promotes a patient-centric approach and expedites treatment pathways. Real-world application, case study IoT in action, chronic illness management and predictive analytics, showcase transformative impacts on healthcare delivery, highlight how IoT elevates patient care standards. The future of healthcare, ongoing evolution and proliferation of IoT, promise of reshaping healthcare with interconnectedness and efficiency. Ushering in an era of personalized, data-driven medicine. Embracing the future, as IoT continues to advance, its potential to revolutionize healthcare is immense. By leveraging connected technology, we can achieve higher efficiency, better patient outcomes, and a more personalized approach to medicine. The future of healthcare is here and it's connected. Next, I will pass to Brian Ling.
Thank you, Jason. And now I will present the benefits of IoT in healthcare. Day-to-day benefits of IoT in healthcare. First one, enhanced patient monitoring. Real-time data from wearable sensors and smart systems. Continuous tracking of vital signs. Early detection of health issues, timely interventions. The second one is improve patient care and treatment outcomes. Personalized healthcare through individual health data and analysis. Customized treatment plans, for example, smart inhalers and asthma. The third one is increase efficiency in healthcare operations. Smart inventory management to prevent supply shortage. Predictive maintenance of medical equipment to minimize downtime. The fourth one is remote patient monitoring. Smart watches and fitness trackers for home monitoring. Benefits for chronic disease management. Reduce need for frequent hospital visits. The fifth one is support for telemedicine. Facilitates virtual consultations, especially in remote areas. Save time and costs for patients. Manage healthcare provider workload efficiency. The final one is addressing challenges. Importance of data security and privacy. Need for robust security measures against cyber threats. Interoperability between different IoT devices and systems. And that's all for my part, and I'll leave the next one to Shipping.
Okay, thank you, Brian. I'll be explaining about technical design in healthcare now. So in our technical design, we are creating an IoT healthcare system that involves integrating multiple healthcare monitoring devices and software to gather and analyze patient data, as well as the system has many levels that operate together flawlessly. Firstly, it will be Bluetooth. This is a device layer that's made up of sensors and wearables, for example, smartwatches and fitness trackers. And these devices interface the system via Bluetooth, Wi-Fi, and LTE, or with 5G. Secondly, it will be the cloud layer as it acts as a data storage platform such as AWS or Google Cloud that can manage large amounts of data safely, as well as cloud computing resources use real-time analytics and machine learning to provide useful insights to doctors and patients, as well as the application later includes user interfaces like mobile apps and websites that allow patients and doctors to access data and receive notifications. And with the integration of electronic health records, EHR, they can ensure patients' records are updated on time. Thirdly, due to the importance of security and privacy, we've decided to implement role-based access control, or also known as RBAC, and MFA multi-factor authentication that are required for user access and data restriction respectively. By using AES 256 encryption, it is used for at-rest data encryption, whereas SSL TLS is used for in-transit data encryption. And to ensure adherence to legalization like GDPR for EU individuals and HIPAA in the US, we can guarantee that the system maintains stringent privacy requirements. Finally, in our technical design, we have implemented continuous maintenance and monitoring that are essential, including frequent updates and upgrades to address security flaws and add new features as well as real-time system health monitoring. Next, in hardware in healthcare, we have implemented or we are trying to transition from bulky stationary machines to portable devices that are easy and not as expensive, such as using wearables for proactive health monitoring in home care settings that is not restricted to the hospital environment. One of the key sensors used in our project would be a continuous glucose monitor, where this sensors uses electrochemical sensors that measure glucose levels in the interstitial fluid, while using optical sensors that can estimate glucose concentration through the skin using light-based techniques. Secondly, would be a blood pressure monitor, where the sensors used here would be oscillometric sensors that can measure the atrial wall oscillations during cuff deflation, as well as piezoelectric sensors that convert mechanical pressure changes into electrical signals. Thirdly, will be heart rate monitors, where the sensors used here are reflection type pulse sensors that emit and deflect reflected light such as infrared, red, green to measure blood flow rate changes. That's all for my part. I will now pass it to Ashwin.
Hello, a very good day to everyone. My name is Ashin, and today I'll be going through the IoT software implementation in healthcare. So let us go through the overview of the software implementations in IoT healthcare. The software utilizes AI, advanced data analytics, to improve the healthcare outcomes. And there is also a continuous monitoring and analysis of patient data for proactive health management. Now let us go through the software platforms that is included for IoT in healthcare. The first one that is commonly used is the IBM Watson Health. It is an AI and data analytics for real-time monitoring and predictive healthcare. And the sensors used in this software platform are the vital sign sensors, such as the heart rate and blood pressure, and also the glucose monitors. The second software platform is Philips Health Suite. It can integrate clinical and telemetry data for continuous patient monitoring and virtual consultations. And the sensors used in this software platform are the vital sign sensors such as the heart rate and blood pressure too, and smart devices for remote monitoring. The third software platform is the Bedtronic, which is remote monitoring for patients with defibrillators and pacemakers. And the sensors used in this platform are the cardiac rhythm sensors, which is known as ECG sensors, and also device performance sensors. The next one is the GE Health Cloud. It is a cloud-based platform for storing, sharing, and analyzing medical images and health data. And the sensors used in the software platform are imaging devices such as MRI, CT scanners, and X-ray sensors. And also, it has a data integration from various medical imaging modalities. Last but not least is the iHealth My Vitals. It is a mobile app and cloud-based platform for tracking vital signs and health indicators. And the sensors used in this platform are heart rate sensors, blood pressure monitors, blood oxygen saturation sensors, and activity trackers such as steps and calories burned.
Okay, thank you, Ashwin. Now for the proposed projects. In our proposed project, the technical design, we have decided to use Macpros as servers to process the data collected from doctors, as well as using the implementation of AI and ML models to learn and take the data from patients to better predict and suggest the diseases and treatments that the patients need, as well as it will integrate a robust cloud interface to ensure scalability, secure data storage, and efficient communication. Firstly, the hardware design here that we're using will be a Mac Pro, and the reason being is because it has a very high processing power, high storage, and a fast DDR4 memory, which is able to handle heavy loads while ensuring ease and minimum latency with optimal performance. And these hardwares as well will be tablets and wearables for doctors that can also enable patient monitoring with patient monitoring sensors. In our design, we have a cloud infrastructure to compute and store services, such as we're using AWS, Google Cloud, and Microsoft Azure. And for networking, to keep everything interconnected, we have Cisco ISR 1000 series routers and Cisco Catalyst 9000 series switches, along with Palo Alto Networks firewalls. And to ensure that the data is secure, we have hardware security modules such as AWS Cloud HSM and Azure Key Vault HSM, along with MFA devices like YubiKey and Google Titan Security Key. For the for the user interface hardware, at the doctor's workstations will be a 16-inch MacBook Pro that is equipped with Apple's latest M3 Pro or M3 Max processors that is capable of providing up to 128 gigabytes of RAM and memory, along with 8 terabyte of SSD storage, and a very clear and beautiful display so that the doctors are able to view the results clearly. As for patients' devices, they're able to use smartphones and tablets that are compatible with iOS and Android that have the latest processors and a minimum of 4 gigabytes of RAM, as well as offering 64 gigabytes of storage that can be connected via Wi-Fi, LTE, or 5G. For the integration of these devices, we have protocols such as MQTT, CoAP, and HTTPS, and we're using advanced data encryption standards like AES-256 for the data at rest. To configure this, we are implementing VLANs to segment traffic and enhance network security performances, as well as using firewall rules and VPN. And we have regular security audits and compliance assessments, as well. Following that will be automated backup procedures. That's all for my part. I will now pass it to Ashwin to further explain our software design in the workflow.
So now I would like to go through the software architecture of our proposed solution to IoT in healthcare. So let's go through phases by phases. So the first phase is by collecting real-time data from IoT wearable gadgets and monitoring tools from patients. And this real-time data will be sent to cloud platforms such as Amazon, Google Cloud, and Azure. And in this under cloud processing systems, so there'll be data security. That means which means that the data will be stored and secured uh, with the ability of the identity access management, which is abbreviated as IAM. And also it is stored as the databases using NoSQL or SQL. So the next one is the doctor interface, which means there is an interaction between a doctor and patients by asking the patients what kind of symptoms you have, and then they'll be identifying the sickness. So the doctor interface can be created using a mobile app or a web portal using either Flutter or React Native. And this platform will act as the patient management system, which means that we can input the symptoms from the patients by asking them inside the doctor interface system, patient management system. And then after that, this data will be collected and then will be sent for symptom analysis engine using AI ML, where it can be integrated with AI and ML to identify the symptoms by using models such as TensorFlow, Keras, and Scikit-learn. And then the third phase is by using the cloud services with the API gateway, which can be used as a Node.js or Express.js, and this data will be sent to the business logic, which act as the microservices. So under this business logic, there'll be a symptom analysis engine with AI or ML, which can integrate with the data that will be sent by the cloud services. And then there's also a treatment recommendation engine, which means that once the symptom is identified and the disease is identified as well, there'll be there'll be treatments that can be recommended to cure the disease. And then the data will be stored as the patient's records in a MySQL database. And this whole system is regulated by General Data Protection, which is abbreviated as GDP, and also HIPAA, which stands for Health Insurance Portability and Accountability Act. So under General Data Protection, patients must give explicit consent for their data to be collected and processed, and then only patients have the right to access their data and can transfer it. The next one, under the HIPAA, we can ensure that all patient data is handled with the compliance of PHI regulations, which means that it is a protected health information. And also, it can apply technical and physical and administrative safeguards to measure the confidentiality and the integrity and the availability of electronic PHI, which is abbreviated as ePHI. That is all from me. Thank you.
Okay, thank you, Ashwin. Now, for our tangible output in this project would be real-time monitoring for doctors, which allow healthcare providers to intervene promptly, thereby improving patient outcomes. And the integration of an iPad Pro and the 16-inch MacBook Pro helps doctors to immediately notice any changes in their patient's health, as these devices are seamlessly integrated, as well as embedding AI and ML models into the system. Now, our business model will be based on subscription-based models where the user or outside third parties can pay a regular fee for accessing the system services, as well as providing a steady revenue stream to make the healthcare industry more advanced and available to a broad range of providers, including small clinics and individual practitioners, as well as a varying level of service that caters to the needs and budgets of different healthcare organizations. As for pay-per-use model, we allow healthcare providers to pay only for the services they use and to ensure that even smaller practices can benefit from cutting-edge technology without incurring high costs. And for our market scope, we plan to implement this in hospitals, clinics, and private sectors where they can benefit from the system's enhanced patient care capabilities, improve operational function and efficiency, and advanced diagnostic tools, which offer real-time monitoring and personalized treatment plans due to our AI and ML models. As for government and public health organizations, they can use the system for population health management, disease surveillance, and public health interventions, which can help these organizations to identify trends, allocate resources more efficiently, and implement targeted health interventions to improve public health outcomes. As for academic and research institutions, the data collected can support various research initiatives, contributing to medical advancements and innovations, and on top of that, can analyze large data sets to identify new treatment approaches, understand disease patterns, and develop preventive measures. For a centralized healthcare database, we aim to improve the continuity of care, reduce redundant tests, and enhance the overall patient outcomes and the experience. as well as we want to design it to be interoperable with different hospitals and clinic systems. And we would like to also store detailed patient records, including medical history, previous diagnosis, treatment plans, medications, allergies, lab results, and imaging reports. And to prevent any misuse of data, an audit trail feature will be incorporated. To implement this, a pilot program will be conducted in select hospitals and clinics to test the functionality and security of centralized healthcare database, as long as we will receive feedbacks from healthcare providers during the pilot phase, and we will use to refine and improve the system. The training sessions will be conducted for healthcare providers so they are familiar with the system, and there will be a collaboration with key stakeholders with regular updates being deployed. That is all from us today. Thank you.